Hi friends, welcome to follow up. Let's have a look at problem 2841, maximum sum of almost unique subarray. In this video, we're going to explain how to use data structure to solve problems. And the technical aspect for this problem is sliding window. So here we are given an integer array called nums and two positive integers m and k. So our task is to find the maximum sum out of all almost unique subarrays of length k of nums. If no such subarray exists, we are going to return 0. So here a subarray of nums is almost unique. It means that it contains at least m distinct elements. So here this problem actually is rather straightforward, especially due to the restrict that the subarray should have length k, right? This actually simplifies the problem. So here we have 3 examples. So we will look at the first one. Actually here the length should be k. So if we look at the first 4 elements, so there are 4 unique elements, which is greater than 3. So it's a valid almost unique subarray. And this sum is 18. It's also the return for this problem. In this explanation, it lists all the possible almost unique subarrays of size 4, right? So you can compute their sums and then do the coding or interpret the output. So here the constraints are the following. First, the list can be as long as 2 times 10 to the power 4. So in other words, we need to consider term complexity. So the second one is a consistent one. So m is greater than or equal to 1 and less than or equal to k and less than or equal to the length of this list. And here the last expression, the elements is positive. So this actually plays some role in the coding part. We are going to point out this little point. So with that said, we are ready to do the analysis and do the coding. So here, as we mentioned at the very beginning, so the strategy will be using data structure to solve problems. And also, we are going to use sliding window. So more specifically, from data structure aspect, so we are going to use dictionary or hash map in this coding part. And from logical part or aspect, we are going to use sliding window. So here the sliding window, the window is fixed of length k, right? So for each window, we are going to check the number of unique elements and possibly its sum and do possible update on the sum. So these checks are actually done with the help of dictionary. So with that said, let's look at the coding part. So let me first initialize a result variable. So we are going to return its final state. So also let me introduce another variable, that is the length of this list. First, if n is less than k, in other words, no such almost unique subarray. So we are going to return the current state of result according to the problem requirement, that is 0, right, as here. And next, we want to first look at the first key element to check if it's almost unique subarray. So let's do it in a verbose way. So here, let me use a dictionary first to initialize this. This dictionary will play the role as we mentioned above. And then let's also use distinct. So that is the number of unique elements. Currently is 0. And then current will record the sum in the window of length k, right? And then we are going to first look at the first key element. This is also a base from which we are going to iterate. So for I in range k, right? So the logic is that if nums I are not in the dictionary, so it means that the number of distinct elements is incremented by 1. So anyhow, we are going to update the counting of this nums I. So it's going to be get nums I if this key is not in the dictionary yet, so the default value will be 0. Then we are going to increment by 1, right? So then the current sum is incremented by the current number, right? So this is the base case. So in other words, we first compute the sum of the first key element, and then we check if this key element corresponds to a almost unique subarray. If so, we are going to update the result variable. So let's do this. If n distinct is greater than or equal to m, right? So in this case, we are going to update the result to current. So because here we computed sum, right? So this current is always greater than the result variable we initialized. This is due to the small point we mentioned. So the element is strictly positive. So if we do not have this positivity assumption, so here what we can do is this. So we can do this. But you need to use a sufficiently small initialization for the result variable, right? So in this problem here, so it's enough to directly set result to be current. So here, let me make a comment. In each result small enough. So this is a small detail, but it's actually important to know in general for general coding. So next we are going to do sliding window, right? So this is actually very simple. So we are going to add in queue. You can understand this as a queue. In queue an element, and then dequeue the oldest one. So basically for I in range k up to n-1, right? Then because the sliding window towards the right, then this element nums I minus k is going to get popped, right? So we are going to decrement its counting by 1. So if each time we decrement this, also we need to decrement the current, right? The sum I minus k, right? So now what we want to check is if this the occurrence of this nums I minus k is 0, right? Then we need to delete this key, or we can also need to distinct minus equals 1. So for cleanness, let me also delete this key, though it's not absolutely necessary, right? So, but for this problem, it can be important. Let me make a correction. It's important to delete this one because later we do not assume that the elements in the nums list is unique, right? So if it's unique, we just need to directly look at the list key subarrays. So no, this is important. So after we do this, then we are going to enqueue nums I. So if nums I not in D, right? That's why we need to do this delete. And then we are going to increment the A distinct by 1. So no matter what, so we are going to update this counting or frequency for this one to be D get. So let's look at if it's already in the dictionary, right? If not, we are going to set it to be 0, and then we increment by 1. So as we add this nums I, so the current will be incremented by nums I, right? So this actually finishes the let's call this one dequeue operation, right? So though we do not explicitly using the queue, so this one is enqueue operation. So after this, so what we are going to do is to update result variable, right, or state. So here the criterion is that if n distinct is greater than or equal to m. In other words, it means that the current window we are looking at is a valid, almost unique subarray. If this is the case, so we're going to do result max and current. And after this loop, so we are ready to return the result state. So this forms a complete solution to this problem. So here we write with a lot of details. Actually, you can use one for loop to do all the things. But for explanation purpose, we make this longer. So before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Now here it's wrong. Let me check what's the problem. So we have results and the length if n is less than k. So we're going to return this one. So we set a dictionary and the distinct and the current equals 0. Then we do the for loop, right? If it's not in D, so we increment the distinct, and then no matter what, so we're going to do this, right? And then we get this part. Also here, less than or, so we are going to use greater than or equal to. So now let me check. Yeah, it passes all the test cases. So it's important to notice the typing when you do the logic. So your logic might be right, but what you type might be different from your logic. So with that said, I guess that's basically about it for this specific problem. So here the main takeaways are the following. First, we need to keep in mind that we need to use data structure to help solve problems. So this is the one part. Another part is that when we do sliding window, so we need to do some clean up work like this part. This is important for this problem. So with that said, that's about it for this video. Thank you.